For many people, data structure is a frightening concept. But believe me when I say that once you begin studying and practicing them, you will acquire both confidence and proficiency. And then definitely you can put this valuable expertise to use while dealing with hackathons or real life software development projects. And to help you get started with this grand endeavor, today we bring you this video on Java collections, which are majorly used to create almost all types of data structures in Java programming language. But before we dive into the intricacies of this concept, a subscription to our Intellipaat channel would be much appreciated. First of all, we shall look into the agenda for today's session. We will begin this session by understanding what is Java collection. Next, we will understand why Java collection framework was introduced. After that, we will learn about collection framework hierarchy. And finally, we will dive deeper to discover details about collection components such as list interface, queue interface, and set interface. I hope I have made myself clear with the agenda. So without wasting any time, let's get started with our first topic, what is Java collection? So, without wasting any more time, let's get started with our first topic, what is collection in Java? A Java collection is a container that can hold multiple items in a single storage unit. The items contained in these containers can all have multiple values. There is no need that all items should be of a single data type. Furthermore, these collections are dynamic in nature, which means they don't have any fixed size. If you feel that you want to add a few more elements during the runtime or even execution time, you can do so with collection, which is not the case with finite or static data structures. The collection framework, which came along with JDK 1.2 release, evolved the definition of collections, providing proper architecture to develop data structures in Java and to perform multiple operations on them, such as searching, sorting, insertion, deletion, or any sort of manipulation. Furthermore, all these mentioned operations are built-in functionalities of collections. Unlike regular data structures, you are not required to worry about writing code for each custom operation. You'll just have to invoke a method from collection and it will do your task. This sounds quite effective, right? Yes, indeed it is effective. Let me tell you why. A collection framework is a set of classes and interfaces which provides a ready-made architecture to develop new features and perform operations on them. However, the question that arises is, why to define a framework for implementing a new feature or a class? There is no such requirement for that, right? But let me tell you, prior to the JDK 1.2 release or a collection framework release, standard methods, Java objects were arrays or vectors or hash tables. And since there was no common interface to all these collections, they were defined independently, which means for the same operation, programmers had to remember different methods for all three collections, their syntaxes and constructors too. This was quite tedious and ineffective for community programmers. So Java developers decided to find a solution to this problem. And that solution, collection architecture or framework. Under the influence of one interface, all different collections became more unified, making data structure programming more effective, efficient, and reliable. The other change that came along with the collection framework is that the vector class became accessible. Primarily, all vector methods were final, meaning you cannot use the vector class to implement similar type of collection. But now, you can extend the vector class to create your own new custom class. I hope that you are clear with this explanation. Moving ahead, we will discuss about the collection framework hierarchy. The collection framework hierarchy starts with the iterable interface, which is basically a root interface for all Java collections. And it stands to signify that for each manufactured data container from collections, the item values can be traversed one by one. Simply put, if the data container is not iterable, you won't be able to access or traverse its elements. After iterable, we have collection, after which we have list, queue, and set. All of these interfaces inherit the properties of collection. After that, we have array list, linked list, and vector. All of them inherit the list interface. The vector class has one more child named as stack. Then we have priority queue class implementing the queue interface. DQ is another child of queue, however, it is an interface. DQ also has one child named as ArrayDQ. Under set interface, we have hash set and linked hash set. Then we have sorted set interface extending the set interface, which further includes a tree set class. Now you can see the two types of connecting lines here, right? Remember, the ones that are dotted show the implementation by classes, whereas the dark lines represent the extension. All this structure is known as collection framework hierarchy. Now let's discuss more about interfaces before going into the details of hierarchy components. The interfaces are basically rule books. They define the rules that must be followed by Java objects. Let me give you an example to make this more clear. Consider the health regulation department as an interface. The HRD sets multiple rules and guidelines to be followed by the general population to limit spread of any sort of health disease. Take an example of COVID per se. The HRD initiated a protocol that everyone should keep a distance of 6 feet or 2 meters while standing in a public area, which is a rule, right? They also made an announcement that if any person feels like having the symptom of COVID-19, they should visit the nearest testing center and get themselves isolated or quarantined. Wear the mask while leaving your house. All these are rules, or let's say definitions of rules. However, it's up to me to decide whether I want to wear a premium and costly N95 mask or more regular and cheap use and throw mask, or for that matter the mask with red color, white color or black color depending upon my choice and wardrobe, right? But to go outside, I'll have to follow these guidelines at any cost. This same scenario applies for Java interfaces. You'll have to follow the guidelines set by interface if you are going to implement it. Not only that, but you'll have to define each method of your interface inside the class to successfully utilize its functionalities. Let's look into a few properties of these interfaces. First one is they cannot be instantiated. Neither you nor the runtime environment can create its object. Interfaces cannot create constructors or fields. They can only contain abstract methods. So, if you write the class which is the structure of an object, you can implement an interface. Interfaces are implemented by classes. An interface can extend multiple interfaces. All these are the main properties of interfaces. I hope this is clear to all of you guys. Let's look into the details of the base interface of collection. As mentioned before, the iterable interface provides the iterative facilities to data containers. For example, let's say you got the data structure named list and you have multiple elements stored inside it. So, only because the list inherits the iterable interface, you will be able to iterate through its elements one by one. The iterable interface inherits the iterator interface, which has three functionalities shown on the screen. These methods basically help the iterable interface to achieve iterations. Collection interface extends the iterable and has all the methods that all other child interfaces or classes will implement. Now, we'll start looking into the details of data structures or components of collection hierarchy. Our first topic is list. So guys, what is a list? Well, a list is a data container that extends the collection framework and stores the elements in an index approach. It supports the redundancy. That means the same values can be added into the list multiple times. Array list, linked list, and vector are the three classes that extend the list interface. Let's discover them one by one. The array list is an implementation of a list that can dynamically add or remove elements. The data which is added into the array list is most often added in an index format. Array list almost behaves the same way arrays does, except the fact that they are dynamic in nature and their sizes can be reduced or increased during any instance of time. Suppose you want to create a project for library management system and you need some sort of data container to store the name of books. In this particular case, array list will be the best option for you since you can change its size as much as you want. Plus, it will give you a more indexed listing of your books. The syntax for creating an array list is given on screen. It goes like array list object equals to a new array list. On that note, let's move to the linked list class. The linked list class is again an implementation of list which can dynamically store elements in non-contiguous format. Basically, it's made up of two fields, a data field and address field. The data field stores the elements, whereas an address field stores the address part of next node. There are two types of linked list we have, namely singly linked list and doubly linked list. The node structure that we have discussed previously is considered as singly linked list node structure. The linked list looks something like this. The head flag available here stores the location of first variable, whereas the last variable will contain null value in its address part. In case of doubly linked list, we have three fields, one data field and two address fields. In the data field, you'll find elements, whereas the address field will contain reference of next and previous element respectively. Web browser history, the back button and the forward button is the right example to understand how you can use linked list. The web browser history can traverse its way in both the backward and forward direction, just like the doubly linked list, because of their ability to store both previous and next stages. The syntax for creating this linked list is quite simple. You'll just have to write linked list object name equals to new linked list and your instance of linked list will get generated. Next, we have vector. Vectors are similar to arrays. You can access their elements with any index except the fact that they are of dynamic nature and completely synchronized. Because of this distinctive feature of synchronization, they are also considered thread safe, which simply means that only one thread can work on a vector at a time and the rest of all threads cannot perform other operations on it until the first thread releases the lock. The syntax for creating vector is vector object equal to new vector plus inside it will add few parameters named as size and the increment. Moving forward, let's learn more about queue interface in Java. Queue interface in Java follows the FIFO approach for inserting and removing the elements, which simply means the elements that are going to enter first will also leave the queue at first, and the elements that are going to inserted at last will also leave the queue at last. The structure of queue will look something like this. It will remain open from both of its ends. The rear end will insert the elements and the front end will simply remove them. To understand this better, consider the example of movie ticket queue. The person who enters the queue first will receive the ticket first and the person who enters the queue at last will definitely receive the ticket at last. Also, both the ends of this queue remain open. However, the entry can only be made from rear side and exit can only be done from front side. This is the exact concept that queue in data structure abide by. There are basically two types of queue we have here in collection hierarchy, named as priority queue and double-ended queue. Let's start with priority queue. The structure of the priority queue remains the same as of queue. The only difference is that elements of the priority queue have some sort of priority assigned to them. This priority can be value specific as well. For example, the element with lowest value will have highest priority or vice versa. Basically, a heap data structure is used to implement this order. Another type of queue we have is DQ. The double-ended queue inherits properties of both stack and queue. It can perform both insertion and deletion at both of its ends. That is why it is named as double-ended queue. The real-life application of queue will be the food delivery applications such as Swiggy, Zomato or KFC. So, when a customer places the order, he enters into the queue. If he is the first one to place the order, he'll be served quickly. Otherwise, he will have to wait until the order in front of him gets delivered. I hope this makes sense to all of you guys. Finally, let's discover the set interface of Java collection hierarchy. The set is a collection that focuses on uniqueness of elements, which means the same element won't be allowed to be stored over and over again. To map only unique elements, the set uses hashing function. Here, we have three subtypes under the set interface named as hash set, linked hash set, and tree set. Let's discover the hash set first. In case of hash set, the elements are stored inside the hash table to make sure that all entered elements don't have any sort of duplicacy. The insertion order is not maintained by hash set. Elements are added here based on their hash code. It is also considered as the best approach for performing search operations. And the syntax for creating hash set is hash set then data type object equal to new hash set. Next, we have linked hash set. As its name implies, linked hash set is implemented using both linked list and hash table. As same as hash set, it will again provide a unique set of elements. Only benefit it has over hash set is that this class will provide maintained insertion order. Basically, this is achieved with the help of linked list. The linked list maintains the track of how data is getting inserted for us. The syntax for creating this link hash set is link hash set, then data type, then object name, and then equal to sign, and then new link hash set. Finally, we have a tree set. Tree set class implements the set interface that uses tree data structure to store the elements. The data we are going to add to this container will be unique and it will be sorted in an ascending order for us. So, this functioning is done automatically when you implement a tree set. The syntax for this tree set will be tree set, then data type, then object equal to new tree set, and then again data type. This brings us to the end of this session. I thank you all on behalf of Intellipaat team and wish you all the very best on your endeavor of mastering data structures.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job.